How would you go about finding the area of a regular hexagon? Who'd like to come up here and show us how they did it? Any volunteers?
You can do it on the board if you want.
Yeah. Board is always the best thing to do.
I just figured they're all equilateral triangles, and since we're doing one side, then I know what this side is. I treated that as a square, that as a square. So it's the 64 minus 16. So this is this times that would give you that as a rectangle, and if you multiply that 6 times, because you've got the 1, 2, 3, 4, 5, and 6. Does that make sense? Sort of, kind of, maybe.
Does everyone understand that? So you're saying 6 times this, or how much more times this would give you?
So you've got the square root of 48 times 4, so you have the base times the height of a triangle. I didn't divide it by 2 because I'm using 4 instead of 8 as the whole base. And so then I just essentially have, if I was to flip one of those triangles into a rectangle, I have 6 of those little rectangles, and so I
You multiply this by 6, is what you're saying.
yeah, so 4 times the square root of 48 times, 4 square roots of 48 times 6.
4 times the square root of 48 times 6.
Yeah, because it's the one side of a triangle times the other. I didn't divide by 2 because I'm just
Yeah, got that.
counting there. And then there's 6 of those sets, and so you just multiply by 6.
And what's the answer then?
I don't have the decimal out. I just did it's the 24 square roots of 48. You can reduce it farther, but
So that's, we'll see. I'm off the top of my head if that's right. Sounds, you'd be close if you weren't.
My only question is, how did you know the length of the?
At the bottom?
Yeah.
so this is an equilateral triangle, so all sides are the same length. And so I know that if I bisect that angle and make the right angle, it's going to be halfway between the two. And so I know that even though this whole side is 8, I'm only taking half.
Yeah.
So I've got 4.
Do you see why it's an equilateral triangle?
No, I don't see why.
Okay.
Like, I don't know how you just. Did you just know that it's an equilateral triangle, or is it a principle?
Yes and no. Just
That's always
everyone here is taking the test, right?
That's close.
Yeah.
Oh, well, yeah.
Yeah.
Do you remember one of the extra credit questions was making a regular hexagon? And then you had to divide it into like 4 equal parts and then 8 equal parts.
Oh yeah.
And so if you really wanted to go about it a really long way, since we know how many sides there are, we can figure out what the interior angle side is. And so each one of these angles is 120. And so if I bisect them into the center, then that makes that a 60, and I do it here, and that'll be 60, which will leave 60 there.
Gotcha.
Does that make sense?
Yeah.
Does everyone see why these are all equilateral triangles? Good. Is there any other way someone came up with? It's the only way y'all did it? Okay, I'll share with you one more way. There's actually 3 ways in your key. One way is by, bless you. You have your regular hexagon and you just cut it in half. And then you have 2 trapezoids. So in here we know the formula for area of a trapezoid is base 1 plus base 2. Well, now we have 2 of them. So multiply the whole thing by 2. And that'll give you the area. Now the question is, what is the height and what are the bases? Can we find those? Is there enough information given to find those?
Yep.
Yes.
Okay. What are the bases then? Bless you.
8 and 16.
16. And the height is,
Square root of 40.
it's the same thing, same process. You do triangle and find the height. Cool. Good. Okay. So how would you, next topic is about averaging numbers. How would you average a number? Or a group of numbers, let's say. What would you do to average numbers, I guess you'd say? Does that make sense?
Average them,
So you have a group of numbers, and how do you find the average?
add them and divide by how many there are.
That's one way. Any other ideas come to mind? Or do you know why it comes like that? Why it works?
If we wanted to do it in a physical format, then if you took and you just take pieces from the highest one, the greatest amount, and spread it out evenly until you get down to the next level. You're just
That's exactly what's going to happen. We get to have an activity today. We each get to have some blocks. And so I'm going to give you some numbers. The numbers are 4, 7, and 10. I'm just going to have to share these. And from those numbers, find the average. Can you share with her? You can work in groups of 2 or 3.
I don't know if this is, I don't know, I just took off 3 from the I just did that, so, and if you counted them all up regularly and divided by 3, that's another way, and so it's 7.
And how many high is it?
7.
That's exactly what we're doing. So I'll give you another group of numbers now. Some will do 5 numbers. Let's do 4, 6, 7, 3, and 10.
Okay. 6 or 5?
How do you know?
I looked at that.
How many numbers do you have?
5.
5. So there are times when your average could be 5. Say if we have 5 numbers and they all added up to 25. 25 divided by 5 is 5.
Okay.
But notice your numbers, how many numbers you had, or so you have 5 numbers here. Each number you can say is a group. And then your height is going to tell you your average. Does that make sense? So just think of it as groups and then your average. Cool. In your homework, you were asked to review polyhedral shapes, and we're supposed to go over the definitions of them. So, what is the definition of a net? Does everyone remember what the definition of a net is?
Is it like the total number of edges and vertices? Like sides? I can't remember the
It's
Not
alright.
the total, but like, yeah, so like the total number of edges and then the total number of vertices, the total number of faces.
That has something to do with the net. What is the physical definition of a net? Yeah, I believe you guys understand. It's alright. So we have a cube here. But a net is the 2-dimensional look of this. So basically, if I folded this out, no. That's the net. It's the two-dimensional physical representation of how you get a 3D image. So this is the 2D. The 3D is the 2D. Now you mentioned the edges and the vertices. That's important. If we draw it out, well, that's a vertice, that's a vertice, that's a vertice. Those are all edges and vertices. And what is this called? On the
Space.
base, correct. What is this called? See, a better application would be, what is that?
Base.
Base. Yeah. And what's the different way you could say a base? It's a special type of face that you just rest upon. So it's the bottom or the top. Think of a trapezoid. See if you have a trapezoid in here. We do not. But if you had a trapezoid, if you had a 3D image, you have a base 1 and base 2, and those are the top and bottom faces, are called bases. Cool. What's a lateral face?
A face is not face.
That's pretty good. Yeah, essentially what it is. See if I can give you a... trapezoid-like figure here. What is the vertices in the three-dimensional image?
That's sort of like 2 or 3 faces in
It's the corner. It's where you have the corner of the vertices. Well, they all meet together. Exactly right.